That's an issue with my internet, so it's cut off for like maybe a minute or so. So sorry about that. So let's go back to the PowerPoint. Okay, we on example number 3 right now. So so we're looking at a mortgage, right? We're assuming this is 30-year mortgage, although it wasn't specified here. Let's look at it as a 30 years mortgage. Okay. And then now mortgage, we know that it's a present value of the annuity, present value of the annuity. Okay. And now it's a 30 years mortgage. So so we're looking at this present value of the annuity formula to find out how much you can afford, right? Like how big of the mortgage you can afford to have in order to pay off the mortgage on time and then with no problem. So let's write out a formula really quickly. R times 1 minus 1 plus R over N to negative NT. And I will get that over R over N. Now here, let's see what we have. So we do know the PMT, right? The regular payment. And we know that regular payment they could afford is $1,450. And they also, we don't know the role. So the rate is not given here. So that's assuming it's 5% rate, right? 30-year fixed mortgage with 5%. Okay, so the rate is 5%, which is 0.05. And then N is 12. Number of compounding period is 12 times per year. And pretty much we could, and the time T is 30 years, right? We know that's 30 years mortgage, 5% interest rate. And now from here, we can just T equal 30. So we're looking for the present value of this annuity right now, meaning how much money the bank is willing to loan you, right? So let's see what that is. So it becomes 1450 that times 1 minus 1 plus 0.05 over 12 and raised to negative 12 times 30, meaning you're still making 360 payments, right, over the life of the mortgage. So 0.05 over 12. Yeah. So again, we need a calculator to do this. So let me show you, or Excel, right? I'm going to show you in Excel. So it's going to be 1450 multiplied by open parentheses for the numerator. It's 1 minus 1 plus rate is 0.05 over 12 and raised to negative 12 times 30. Okay, then close parentheses, that's for numerator. For denominator, you also put into the parentheses. So it's 0.05 over 12. Yeah, okay, we have that. So once you input it properly, we should get a correct answer right away. Right? Here we go. So that means the couple could afford $270,108 and then 30 cents, something like that. Okay. Yes, 2 decimals will be 34 cents, right? So that's how much they could afford to borrow from the bank based on their ability to pay back, right? So let's see, so 270,000. So this amount is approximately $270,108.34, meaning the couple could file the application, right, mortgage application to apply for about $270,000. So based according to that, adding to that down payment, that's how much they could afford to buy the house, right? Okay. Do you have any question on this? Okay. So first of all, look at the financial instrument. So in this case, it's a mortgage. And we know that mortgage have 2 key characteristics, right? First one is a fixed payments, meaning monthly payments. a series of fixed payment. And second element is a present. It's a lump sum comes at present. So we have a lump sum payment at the present time, right? Once you see these two elements, we know that it's a present value of the annuity. Then once you have that, the next thing just apply the formula to get whatever elements they want us to find out. Okay, so this is example 3. Let's look at more examples on mortgage, right? So let's say a house hunter find a house that requires 450,000 mortgage. Okay. Now you know the mortgage amount, right? Let's say they have a 100,000 down payment. The house is sold for $550,000. So they are short of $450,000. So they will borrow from the bank. So what will be the monthly payment on a 30-year 4.25% mortgage? Okay, again, since it's mortgage, we know we're talking about present value of the annuity. One more time. Okay, so now you can write down the present value of the annuity formula. Minus 1 plus R over N to negative NT, close square bracket, R over N. Okay, and now from here, so we are given the mortgage amount. So meaning we know the present value of the annuity, it must be 450,000. They have to borrow this amount in order to finish the transaction. And the only thing we don't know is the regular payment, right? So you're looking for the monthly payment, looking for PNT or regular payment. R is what we're looking for. And we also know a couple of things. First one is a 30 years fixed mortgage. So time T equals 30. And the number compounding period, meaning you pay back monthly payment 12 times a year. And then rate is 4.25%. So turning to decimal with 0.0425. So you know all of this. Now, next thing is looking for the regular payment. Okay, so first of all, let's throw in all the numbers into the formula. So you get 450,000 equal to regular payment. That's what we're looking for. This is 1 minus 1 plus rate is 0.0425 over 12 minus 12 times 30 years mortgage, and over rate is 0.0425 over 12. Okay, so now we need to get rid of this big thing, right? Leave only regular payment by itself here. So typically we just multiply by reciprocals, and reciprocal of this fraction here will be 0.0425 goes over 12 goes on top, and this whole thing, right? Square brackets goes on the bottom. If you want to put into parentheses, you can do that. Dividing by square bracket, 1 minus 1 plus 0.0425 over 12. And if you want to simplify, negative 360 power. Okay. Now on the right hand side, we do the same thing, right? On the right hand side, we multiply by reciprocal. On the left hand side, multiply by reciprocal. So it must be 0.0425 over 12 as numerator, and over denominator, which is square bracket 1 minus 1 plus 0.0425 over 12 raised to negative 360 power. Okay, now we cancel this same term, right, on both top and bottom, and then this get canceled. Now R is by itself, and let's see what the R is. Now again, we're gonna plug this into the Excel to get a result. Okay, one more time, go to Excel. So now we have 450,000 multiplied by 0.0425 over 12. That's numerator, and divided by denominator is going to be 1 minus 1 plus 0.0425 over 12, and then raised to negative 360 power. Okay. And all right, here we go. So we have the right input, and then key enter, you get a result. And so the monthly payment turned out to be $2,213.73. So meaning this is their monthly monthly payment, 2213.73. 2213.73, right? That's what they are obligated to pay back to the bank for 30 years, right? Yeah. So if you think of let's move one step forward. Let's think of total interest paid to the bank. First of all, since this is a monthly payment, right? So for 30 years, the house hunter will pay back this 360 times. So you multiply 2213.73 by 360 times of that monthly payment over 30 years lifetime. And then remember, you only borrow 400, the house hunter only borrowed $450,000, right? Deduct the loan amount, and then the difference is the interest paid, right? Interest paid to the bank, and let's see what that is. Actually, it should be a fairly big amount. Minus 450,000. And this turned out to be $346,942.80. That means bank actually charge you 300 or charge the house hunter $346,942.80 over the life of the mortgage. So this is the breakdown of everything. So you see the big picture, how much interest paid to the bank, all that stuff. Do you have any question on this problem? All right. Let's look at question 5. Okay, so consider two mortgages, each for $400,000 at the 4.5%. One mortgage is for 15 years. Now you have actually two popular ones, two popular mortgage. One of them is 15 years. The other one is 30 years, right? Out in the market. Does anyone know the comparison between these two? What's the advantage or disadvantage of each of this option? Anybody know? Do you know any? You see, you want to share your opinion on this? 15 years, 30 years. Okay. So obviously 30 years has longer term, right? So from a bank perspective, if the loan is longer, it means more risk, right? More risk, meaning the bank will charge you more. So typically 30 years mortgage costs more. Okay, for the clients, right? In terms of customers, it costs more. But remember so this is disadvantage, costs more, right? But the advantage is the monthly payment is lower. Okay, and then compared to 15 years, because it's shorter time, so less risk for the bank, they're willing to loan you at a lower rate, right? Meaning it costs less. But the monthly payment is higher. Okay, so that's a trade-off, because the sooner you pay off, the better is for the bank, right? Remember, the bank loans you the money, so they have risk, right? So the monthly payment is higher. Okay, so this is the biggest comparison between the 15 years and the 30 years. And now if we look at a detailed calculation, we'll be able to see more details. So compare the monthly payments to amortize each mortgage. Amortize meaning pay off. Amortization, right? It's a very technical name for mortgage amortization schedule. Amortize means pay off the mortgage. Okay, each mortgage and total interest paid over the life of the mortgage. Okay, so we need to do two things. First thing, we're gonna separate into. So we look at 15 years first. Okay, 15 years mortgage first. So we are given several pieces of information. So we know that the present value of the annuity here is 400,000, right, for both cases. And then we know the rate is 4.5% for both cases. Okay. So this is 0.045. Okay. We also know time T, 30 years. Okay, and then number of compounding period is 12. Okay. So we know all four pieces of the information. Now, next thing is using the formula, present value of the annuity formula, regular payment times 1 minus 1 plus R over N to negative NT over R over N. Okay, so get that. Now we throw in the numbers. So it's very similar calculation compared to example 4. So we get 400,000 here equal to regular payment we're looking at. So we have 1 minus 1 plus, the rate is 0.045 over 12, and raised to, since it's 15 years, so time T, so I made a mistake here. The time T should be 15, right, because it's 15 years mortgage. So time T 15, 30 years mortgage, the time T is 30. All right, so now this is negative 12 times 15. Okay, as an exponent, it's 180 payments, right? And over 0.045 over 12. So similarly, we will multiply the reciprocal from both sides of the equation to get that. So reciprocal multiply this by 0.045 over 12, dividing over 1 minus 1 plus 0.045 over 12 raised to negative 180 power. This means you're making 180 regular payments, right? Monthly payments to multiply both sides of the equation. So on the right hand side, we'll do it. On the left hand side, we'll do the same thing. 0.045 over 12 and dividing by square bracket 1 minus 1 plus 0.045 over 12 raised to negative 180 power. Okay, so now one more time we cancel all these terms. So regular payment remains, right, on the right. So this R is approximately, is using Excel. So it'll be 400,000 multiplied by 0.0425 by 12. Okay, and dividing by 1 minus 1 plus 0.0425 by 12, and we raise to 180 power, negative 180 power. Yeah, and close parentheses. That's the proper input. I want you to have that, and just hit enter. We get a 400,000. Yeah. So the monthly payment turned out to be $3,909 and then also 11 cents, right? We run it to 2 decimal place, the dollar sign, 3,009 and then 11 cents. So this is the monthly payment looking at $3,009 $1.11. Okay, for the 15 years. So if you look at the total interest paid, so total interest for this account, I guess I put it here. So total interest and so it should be $3,009.11 multiplied by 180 payments times 180 minus loan amount, which is 400,000, and that will be the total interest paid. And let's see what that is. Okay. So $309.11 multiplied by 180 and minus 400,000, and this turned out to be $141,639.80. Okay, so this is how much you pay to the bank, right? How much the bank charge you the interest in terms of interest. Now look at the 30 years one now. It's very similar. The only difference is the time t. Okay, so P is 400,000, same amount of the mortgage, and then rate is 0.045. Then we also have a time t is 30 years, and then n equal to 12. Okay, so we have 4 important elements. Now apply the formula, same formula, principal, present value of annuity, regular payment times 1 minus 1 plus over n to negative nt. Okay, and then over n. Okay, now one more time, we plug in all the numbers. 400,000 equal to regular payment times 1 minus 1 plus 0.045. I think I used 0.0425 for that regular payment, right, for the first 15 years. So let me go back, fix it. Okay. Here I use a 0.0425. It should be 0.045. So the monthly payment will be slightly different. So it's $3,186.12 overlooked. Okay, so here you go. So we're going to modify this to amount. Here you go, this amount. Also this amount. Look back a little bit, $3,186.12. Okay, 3,186.12. $3,186.12. So we're going to multiply that amount by 180.12 times 180, and get that. And then the difference, I'm going to also show you in the Excel, I guess. Now we can do this. We can do this amount times 180 and minus 400,000. Okay, then we get $173,501.66. So let's go back and put in 173,000 by 1.66. 173,000 $3,501.66. Okay, so this is total interest paid to the bank. Now let's go back to the 30 years one, very similar calculation. The only thing is the power becomes negative 360 and over 0.045 over 12. So now let's see what is regular payment. Very similar calculation. Okay, let's go Excel. So here we have 400,000 multiplied by 0.045 over 12. Okay. Divided by denominator 1 minus 1 plus rate is 0.045 over 12, and then raised to negative 360 power. So the only thing different is power, right? This is raised to negative 360,000. Yeah, so we get that. So this monthly payment becomes $2,026 and 74 cents, right? So if you look at this, this is the difference between this is $1,100 and then $60 difference. So this is the biggest comparison between the 15 years and then 30 years mortgage. So here we get a $2,026. Okay. See decimal numbers is 0.74, 74 cents. Okay. 74%. And if you look at so the direct comparison between these two monthly payment, right? It's a big difference. It's a $1,160 difference. If you look at the total interest paid, it also will vary a lot. Total interest paid. Okay, so it will be $2,026.74 times 360 payments of such minus 400,000. Okay, so the difference becomes interest earned, right? So let's go back to the Excel, quickly get that number. So that will be this amount times 360 now minus 400,000. Okay, and this turned out to be 329,626.85. So if you look at it, the interest almost double, right? It's almost double. Twice of this will be 340,000, and then this is pretty close to 330,000. That means over the life of the mortgage, actually the interest amount almost double. The principal amount is not half, right? But the interest amount is almost double, meaning the longer mortgage, the bank charge you more interest on it, a lot more. 29626.85. So this is the comparison. So that matches with the, so this 329,000. 626.85. $626.85. Yep. So yeah. So this is a direct comparison in terms of the monthly payment and also the interest, right? And on both accounts. In terms from the bank perspective, but as a mortgage borrower, you see you pay a lot more for longer mortgage, and also and then the advantage is the monthly payment is smaller, right? It's like $1,160 less in terms of monthly payment. So there's a trade-off. For smaller payment, you have to pay more interest, right? It's like a trade-off. for these two different type of popular mortgages. And do you have any question on this 15-year mortgage and a 30 years mortgage? Okay. All right, so we can move on. Yeah, the interest, we already calculate that. We compare both of them. Okay, now let's look at retirement account now, right? So let's compare the financial condition of two workers. One start to save money early for retirement and put away $300 a month in a retirement account, paying average return of 6%, right, for 40 years. So if you have 401k or any retirement account, on the average market earning 6% is very reasonable, right? It doesn't have to be doesn't take a super, like broker brokerage firm, right? You don't need to hire a top tier brokerage firm. You can still achieve 6%, average return on the regular market. So this is a very reasonable rate for 40 years. The other one starts late and they put away $1,200. Remember, this is 4 times as much, right? So now for another worker, put away 4 times as much into the retirement account and paying an average return of 6%. So same conditions. Now compare the ending balance and interest earned for each worker. And we know that for retirement account, it's retirement account. Typically, we call this 401k or 403b. It depends on if you work for the private companies or the public, or for the government, then 403b, something like that. So now retirement account also have two important elements. First one is the regular payment, meaning you always contribute same amount towards the account, right? So regular payment or monthly payment. One of them is $300, the other one is $1,200. And the other one is the lump sum comes in the future, or one-time payment, lump sum payment. You don't get a lump sum, you don't get a big fat paycheck right now, right? You get it in the future. So lump sum comes in the future. So this is the major difference between the present value of the annuity and future value of annuity is a lump sum. So if you look at this, you get your big check by the time you retire, meaning for women and for men it's different. So usually 65 years old, right? Theoretically speaking. So at the age of 65, you start to withdraw from the retirement account, right? So lump sum is in the future. So now, so we know this is the future value of annuity. So we have to use a formula for the future value of the annuity. So now, first of all, future value of annuity, F equal to regular payment times 1 plus our N to the NT minus 1. Okay, so the formula looks slightly different over our N. Okay. And here we know the regular payment, right? Our monthly payment is $300 for one worker, $1,200 for the other one, and okay, so, and then time T is slightly different too. So for the first worker, save early, right? He save like, contribute towards the account for 40 years. So meaning at a very early age, maybe in his 20s, right? Like 20, 25, start to contribute towards the retirement account. So time T here is 40 years for the first worker. And for the second worker, that's just going to be 10 years. And here rate is 6%. So it's 0.06. All right. And yeah, that's pretty much everything we have, right? Yeah, so we just throw into a number of compounding period is 12, meaning you contribute on a monthly basis per month, right? And we throw into the formula and I get the future value. Let's see, 300 times 1 plus rate is 0.06 over 12 raised to 12 times 40. That's 480 payments towards retirement account. Okay, and over 0.06 over 12. Okay, in the denominator, and let's see what that amount is. Okay, that's a future value, right? In 40 years. Let's go back to Excel. So now let's see, 300 times over parentheses of another one, 1 plus 0.06 by 12, and then raised to 480 power n minus 1. So that's a numerator, and divide by denominator will be rate 0.06 by 12. Okay, and I have it. Okay, have the right formula, right numbers, input it. We get $597,447 and then 22 cents. That's the total account balance, right? After 40 years. Okay, so let's go back and write a number, 597,447.22. $597,447.22. Okay. Now let's take a look at the total interest earned, right, for this account. So think about it. This is total ending balance earned. So total ending balance 597,447.22. And remember, this worker contribute $300 on a monthly basis for 480 times, right? 12 times 40, 480 times. So over the 40 years time, he contribute $300 480 times. And the difference is interest earned. Okay, let's see what that amount is. So let's go back to the Excel, get the amount. So this should be this amount minus 300 times 480 payments. This turned out to be $453,447.22. If you think about dividing this, you see about 76% of this amount is interest earned. So that means it's very high return, right? Over these 40 years. And let's go back 453, 447, and 0.22, 453. So earn a lot of interest, 453, $453,447.22. Okay, so total interest earned. And then total balance. Okay. Now, if you look at the other worker, second worker, look like it's the same condition, right? Now it contributes 4 times as much for 10 years, although the time is shorter, but the amount is much more, right? It's 4 times as much. Let's see the difference. So regular payment, 1,200, and then time T is 10 years. Okay, and then rate is 6%, 0.06, and then N equal 12. Okay, now one more time, we throw into the formula, future value of the annuity equal to regular payment times 1 plus R over N to NT minus 1 and over R over N. Then I'm plugging all the numbers, 1,200 times 1 plus rate is 0.06 over 12 and raised to now is 10 times 12, it's 120 payments, 120 times, right? NT is 120 minus 1 and dividing by 0.06 over 12. And let's see what this amount is. And you'll be very surprised the difference. Okay. So Here you go. So that's putting 1200 multiplied by 1 open parentheses 1 plus rate 0.06 over 12 and raised to 120 power minus 1 and dividing by 0.06 over 12. And once you put it in correctly, and you should get this. So you see the ending balance is actually a lot less compared to the other one. Although it looked like this, you see same condition, but in reality, this ending balance is so much less. You see, it's like 400,000 less in the second scenario, right? So if you want to calculate the interest earnings count, should be this $196,655.22 minus $1,200 times 120 payments, right? $1,200 per month, 120 months in 10 years. Here you go. So the interest earned is only $52,655.22. So compared to this, is like 1/10 as much, even about 1/10, right? So this interest is just not too much. So what this tells us is it's better to save early, although you put away not a big amount, right? But because of compounding effects, time effects on money, right? Time value of the money, it, combined with the compounding, then this amount grows a lot over the 40 years. So this is what implication of this particular example. 196,000. And $655.22. And then total interest earned is this total amount $196,625.12 minus 1,200 times 12 times 120, and we get a difference from the Excel. Difference is $52,655.22. This is 655. So it's 29. 52,655 and 22. $52,655.22. Okay. And let me just modify that. 55. So what this scenario tells us that is save early, right? If you want to save towards the retirement account, save early. Although you just put away very little money, you know, it will generate you a very good return in the future for this retirement account. Okay. I guess we will lecture up to this point. Okay, then we're going to talk about the project number 5. And then if you have any question on project number 4, you can talk to me during the breakout session. I will try my best to help you. So the project, let's go back to the blackboard. And let's look at the project number 5. Most of you guys finished project number 4. And this is due after the spring break. When you come back from the spring break, you can submit the project number 5. Okay. And also, you will have exam number 2 when you come back from spring break. So we are on section 3.3. By the time we finish section 3.4, which is on application of annuities like credit card, all those, and amortization schedules, and you're gonna have a final exam, right? No, the exam number 2, not a final. Okay, okay, let's see. So I'll give you a 1 week notice for the exam number 2 when you come back from the spring break. So probably your exam number 2 will take place on April 16 or 13, right? Either no, April 14 or 16, either one of the day. But I'll let you know when you come back from the spring break. Okay. And let's look at project number 5 really quickly. Okay, let's open the file. Again, it's a Word file, so you will need to come up with the Excel inputs, right, yourself. And basically, it's about compound interest. So graph the growth of money over time in the account yielding 4.5% interest compounding monthly. Start with $100, see how it grows over 30 years. Meaning you got to come up with like after 1 year, how much money in the account, right? 2 years, 3 years, 4 years, all the way to 30 years, right? So you need to have a 30 cells to calculate all these 30 inputs, all these 30 years of the balance for this account. And this is question number 1. And you use this compound interest formula as usual. And then second question, compare the growth of $1,000 investment at different interest rate compounding monthly. So you make a chart showing the future value after 15 years and then 30 years at an interest rate. So yeah, it's like 15 years, saving account, 30 years saving account. Interest rate varies from 2%, 3%, 4, 5, 6, 7, 8%, right? So you need to have 2 different years and with a different interest rate. So put into the same chart. And you also determine how much you have to invest at 2% to obtain the same future value as $1,000 invested at 8% for time t equal 30 years. Okay, so 2%, 8% generate same return, right? How much you need to put into the 2% account. And that's second question. Any specific question on this Excel project number 5? You're still using the same formula, the compound interest formula, and just come up with a sound design, right? So totally up to you. As long as it works and it meets its requirements, so the chart could be designed in any way proper, right? As long as you serve the purpose, it's good. It's good design. Okay, and I guess you could start working on the Excel project number 5. So if you have a individual question you want to ask me, I'm gonna put you in a breakout room right now. You can talk to me on an individual basis. Okay. Yep. So let me put you in a breakout room now. Okay. How about now? Does it work?
Maybe no. I don't know.
Okay. All right. So maybe just actually most of classmates were able to share the screen, but let me see. Or maybe it's okay if you cannot share that. What is your question? Maybe I could just tell you how to resolve it.
Okay. For question 2,
Yeah.
um, I made uh I made a chart, but like I included year and hourly salaries. Is that right?
Yes. How do you calculate the hourly salary?
I divide the total salaries by total hours.
Exactly. Very good. So do you see a clear trend there? Is it decreasing over?
Yes.
Yeah, it is decreasing. So that's good. That means you have the right calculation. It should be decreasing from 2002 all the way to 2007. Once that's the case, you'll be able to sketch the scatter plot, right? And do you know how to sketch the scatter plot?
Yes.
All right, very good. So you just sketch the scatter plot. You go to, let me quickly show you. In Excel, go this insert, and then you will see this chart, right? See this insert scatter, and then you can pick the second option. Now it will give you the line, right? The line,
Yes.
this line, something like that. Then we'll see a clear trend there, it decreasing over time. So that's how you commit. So that means the hourly salary, hourly rate for all the employees actually is decreasing from 2002 all the way to 2007. And that's a very valid reason for the management to consider, right?
Yes.
Yep, very good. So you can just comment that since the salary hourly rate from 2002 2007, it's decreasing, right? So the management should consider give the employees a raise. Make sense?
Yes. So I only have to insert that chart, right?
Yes, you only have to insert one chart. Yes.
Okay. I got it.
Okay, very good.
And for question 1, it said I have to sort it by date and create new one and sort it by check number. So
Yeah.
so I have to have 2 chart, right? Like 2.
Yes, two sheet. It
Oh,
can be
okay.
on the same sheet, but it has to be two like two table, right? One of
Oh, yeah.
them without sorting by check number, and the other one's sorting by check number. Make
So
sense?
second one is I don't have to include the date.
The second one you sort by the date.
No, I
Mhm.
sorted I sort the first one by the date and second one is sorted by check number.
Exactly. That's right. Okay. Very good. That's right.
Thank
You
you.
can use this. Yeah, no problem. All right.
Thanks, Professor. Have a good spring break.